Hi, everyone. Thanks so much to KmerAi AI for inviting me to come speak. I'm going to talk about transforming text data to matrix data via embeddings. I'm a senior data scientist at Data Assembly and located in Miami, Florida. I have expertise in a few different areas, including natural language processing, and feel free to connect with me on LinkedIn or via email. I'll put this presentation along with the data and the code on LinkedIn after the conference. So there's a lot of text data out there. There are chatbots and live agents for a lot of websites collecting data. We can also get text data from customer feedback forms on products or issues that they're having. There's a lot of web scrapers out there to scrape text data from different sources. So being able to crawl different websites can give text data. There are a lot of data lakes out there, especially at universities, that can be accessed, that have repositories on books or articles in certain areas. There's email data. In the educational context, there are student admission essays and other writing samples from students that can be analyzed. And there are a lot of different ways that we can use machine learning to gain information from this text data. So we can classify email as spam or not spam to be able to weed out potential threats. In email systems, we can understand different user groups by clustering chatbot conversations. We can predict which customers are likely to stop their subscriptions based on feedback that we get from them. And we can even predict student educational achievement or attainment from writing samples. However, there are a lot of processes that we need to implement to get from text data to machine learning applications. So a lot of applications require some sort of numeric matrix as their input. So one of the main tasks is to convert text to numeric data. Some of the common ways that this is done is by looking at word counts and frequencies within documents and across documents. So we can encode words as either they exist or they don't exist, as counts of how many times they occur, or as some sort of weighted frequency or inverse frequency of how often they occur within documents or across documents. However, one of the issues with this is we get these really huge matrices that are very sparse. There are lots of zeros and not so many ones. And this can be problematic for a lot of machine learning applications. So one of the ways that we can get around this is through embeddings. Basically, there's a whole field of dimensionality reduction that looks at how to take something that's very high dimensional data and wrangle it down to something that's low dimensional and easier for our machine learning models to be able to process. One of the main issues with this, though, is that context matters. So consider the word bolted. She bolted the door shut. She bolted out the door. Both of these are using the word bolted, but they have very different meanings. And one of the big challenges with text data is this context problem. So we don't just want to understand that the word occurred. We want to understand what it means, what's actually going on in the sentence or in the paragraph or in an entire document. And this is one of the issues. We can solve this with n-grams by looking at sequences of words that occur within the sentence. We can look at this within an embedding context. We can look at this a lot of different ways, but there's a solution out there that really takes into account all of these different needs. The BERT model is a pre-trained neural network that is context aware. For those familiar with neural networks, it's an encoder-decoder structured neural network. that can look backwards and forwards within a sentence or within a document. And it automatically embeds this sparse matrix into a lower dimensional dense one. So instead of having this huge set of data encoding our words and our sentences, we have this smaller matrix with a lot more information packed into it. And Python has a really great package for us to be able to use BERT. And one of the great things about the package that I'm going to demo is that it's pretty easy to train on new sets of documents. So if you have a language that you want to look at in particular, you're able to actually gather data, gather text data in that language and train a BERT model on it. So this is really handy if you're working with different languages. So I'll go into my demo case. Basically, I have a really small data set looking at different poem types, either serious or humorous. And we're going to see how BERT works in practice. So the package that we use is called Sentence Transformer. And this package has a lot of different BERT models, including some that are trained on multiple languages. So I think there's one that's trained on more than 50 different languages across the world. And as I mentioned before, the package documentation shows you how you can extend what they've done with the languages that are supported to include other languages. So once we have that imported, we are able to get our data set imported. And as I mentioned, I'll make this available. One of the important things is to deal with missing data. So in the real world, there's a lot of missing data out there. And this model requires that we have some placeholder instead of just null values. So once we fill in our text that might be missing with a placeholder, in this case, I just use a period so that it doesn't encode an actual word. You can fill that in however you want. We get the BERT model. So this particular training of BERT is multilingual. So it'll recognize a few different languages. And we get the text data from our data set and encode it with BERT. This can take a while to download if you don't have the package installed already. So be aware when you're using that. It also doesn't scale particularly well. So if you're dealing with data sets of millions, you may want to parse it out into smaller subsets for training. The next thing that we do once this is embedded, we want to kind of wrangle this into something that's going to work nicely in a supervised learning model. So we use the NumPy package to turn this into an array. You can see that we have 25 poems and 384 components that came out of our BERT model. This is typical in how BERT is mapped. So even if you have 20, 30, 40,000 different words in the text that you're looking at, you're only going to have a couple hundred components coming out, which is really helpful when you're training machine learning models. So we're going to look at a random forest classifier. For those who aren't familiar so much with supervised learning, this is a really common classifier in machine learning that uses a tree-based model. So you're sampling from your data set, you're building a model, you're sampling again, you're building another model, you're sampling again, building another model, and then aggregating the results of each individual model to get your classifier. So we'll split our data into the training and test set. This is really important. You can have a model that fits the data really well, but doesn't generalize to other data sets. So it's really useful to either do this train test split or something called cross-validation, where you're doing multiple train test splits to train your data and make sure that the model isn't overfitting and that it generalizes well. So we'll fit this random forest classifier. There are a lot of different parameters that you can play around with to optimize the model for whatever problem you're working on. But for this, we'll just mainly use the default parameters. And we can look at the predictions that come out of our model. We predict the poems in our test set to be serious, humorous, and serious. By looking at what the actual values are, we can kind of understand where the model might be missing some of our classifications. And we can see this poem number 13 is a serious poem, but was labeled as humor. The others seem to be correctly classified. And when we look at the accuracy right here, we see that it's 80% accurate. For a small sample of only 25, this is pretty good for a machine learning model. And we can get the feature importances from the random forest model as well. This basically tells us which features are most important for correctly classifying these poems. For the BERT model, they don't mean very much because this is an embedding. It's not actually words. It's just some representation of groups of words that are combined to get to a smaller data set. But if you're working with text data and you happen to have maybe a frequency matrix or some derived features from the text, you can actually see which of those features is most important. So that is how we create a BERT model. I'll stop sharing, and if there are any questions, I'm happy to answer.